Okay, internal resistance. Now please remember, what do you mean by internal resistance? Means internal resistance is the resistance for a battery. Okay, 1 minute. My internal resistance is a resistance which exists for a battery or which is present for a battery. Why and how the internal resistance will be produced, I will tell you. See, for example, if you take a battery, so battery consists of an electrolytic solution. Battery consists of an electrolytic solution. So this is the electrolytic solution. So generally, electrolyte battery consists of H2SO4, NaCl, such kind of solutions. And again, it consists of two electrodes. This is first electrode, which is a positive one, and this is the second electrode. Let us take which is a negative one. Now these two electrodes are connected to a resistor like this. This is the resistor, so which are connected like this. Then what will happen means inside this electrolytic solution there will be positive as well as negative ions. Okay, so inside this electrolytic solution there is positive and negative ions. Now this positive and negative ions will be attracted towards the cathode and anode. So all the cations will attract towards the cathode. Place all the positive charges will move to the cathode. All the negative charges will move to the anode. The cathode becomes what now?
Negatively charged.
Yeah, negatively charged. Then anode will be positively charged. Are you clear? Now please remember, for example, the ions in the electrolytic solution. Okay, the ions in the electrolytic solution. Clear, the ions in the electrolytic solution moves towards a cathode and anode. Moves towards cathode and anode. Okay, now please remember, during its motion, what will happen means it may collide with the other ions. Please remember, during its motion, during its motion, it may collides with other ions. Okay, now what will happen means due to these collisions, okay, internal resistance will be produced. For example, let us consider this is the positive ion. Whenever it is moving towards the anode or cathode, okay, or simply we can call it as electrode. Okay, electrode. Now, when a positive ion is moving towards the electrode, it may collide with the other ions. It may collide with other positive ion or negative ions. Clear? Due to these collisions, what will happen means resistance will be developed. Are you clear? So please remember, due to collisions, internal resistance is developed. Now, due to collisions, internal resistance is developed. Okay. Now, please remember one point, students. This internal resistance depends on few factors. Okay, this internal resistance depends on few factors. What are the few factors? Means first one, nature of the electrolytic solution. Clear? So it depends on what one? Nature of electrolytic solution. Clear, nature of electrolytic solution. So which kind of electrolytic solution it depends, or which kind of electrolytic solution we taken inside the cell. Are you clear? So it depends on that. Shall I move to the next step?
Yes, sir.
Yeah, and it depends on concentration of the electrolytic solution. No, it depends on whom a concentration of electrolytic solution. And it depends on one more factor, nature of electrodes. Okay, which type of electrodes we taken? So what is the material with which the electrolyte is made? Here, what is the nature with electrolytic solution is made? It depends on one more factor, It depends on one factor, area of the electrode plates. Okay, so these are the things on which internal resistance depends. Okay, please note it down. Okay, could you see the screen, students?
Yes, sir.
Sir.
Yeah. Did you copy that one? Did you copy that?
Yes, sir.
Yeah, fine. And remember one point, this internal resistance depends on, remember one point, one, internal resistance depends on these factors we told. Now, there is no cell with internal resistance, I mean, without internal resistance. So please remember, if I take ideal cell, for an ideal cell, internal resistance R is equal to 0. Please note that point. Okay. If you note that point, then I'll go for the next question, next concept.
Yes, sir.
Yes, sir.
Yeah, fine. So now I'm going to calculate the current in internal current with internal resistance. Okay. For example, I will take it as a external resistor R, which is connected to the cell of EMF E, and internal resistance is small r connected like this, positive, negative. Let us consider I is the current passing through the resistor. Now I'll take this point as A, I'll take this point as B, I'll take this point as, for example, C, I'll take this point as B. Okay. Now please remember, capital R is the external resistance, or capital R is the external resistance. Small r is the internal resistance. Now can you tell me, capital R and small r are in series or in parallel?
Series.
In series. Then can you tell me what is the effective resistance?
Capital R plus small r.
Very good, capital R plus small r. Then apply the Ohm's law. So what is the Ohm's law means? Ohm's law is V equal to IR. Okay, Ohm's law is also V equal to IR. So according to the Ohm's law, V is equal to IR effective. Then V can be taken as I into capital R plus small r. Okay, this V can also be taken as EMF E. So I will take V as E instead of V. Okay, I'll take V as what now? E instead of V. Then I is equal to E by capital R plus small r. This is the current through the circuit. Okay, with internal resistance. Please note it down. Then I'll give you few more important concepts from here. Is it done?
Yes, sir.
Yeah. Fine. Listen. For example, the product of current and resistance. So the product of current and resistance will give the potential drop across the cell. Or it will. So please remember, I am writing that point. Potential drop across resistor. No potential drop across resistor. That can be taken as V, which can be taken as I into R. Now please remember, from the above diagram and above equation, how I'm going to write means I is equal to E by capital R plus small r, right? Multiply. If you multiply I into capital R plus I into small r is equal to E. So I into capital R can be taken as V. So V plus I into small r is equal to E. Then E minus, yeah, then we can write like this one. E is equal to, or V is equal to, one more time. Yeah, then V is equal to E minus I into small r. Are you clear? Now tell me, what is V? V is nothing but potential drop across the resistor. No, V is nothing but what? No, potential drop across the resistor. So potential drop across the resistor means potential drop across the resistor is nothing but VBC. Shall I take like this? Because potential drop across the resistor is nothing but potential drop between these 2 points. Am I right now? So that is taken as what? VBC. Did you understand this point or not? No, listen. VBC and VAD are parallel. These points are parallel. Please remember, VBC and VAD are parallel to each other. Therefore, potential drop across AD is equal to potential drop across BC is equal to V, that can be taken as E minus IR. Now please remember, potential drop across AD is equal to, you can write it as V, which is equal to E minus IR. This potential drop across AD is nothing but potential drop across the battery. So that potential drop across the battery, no potential drop across the battery. Please remember, no potential drop across the battery. This potential is called as a terminal voltage. Please remember this point. So what is terminal voltage? Means potential drop across the battery. That is VAD, which can be taken as V equal to E minus IR. So E minus I into small r. That is the potential terminal voltage. Okay. So please note it down. Then I'll go for one more point. You done with this?
Yes, sir.
Yeah, please remember, VAD is nothing but potential drop across the cell or a battery. VAD is nothing but potential drop across the cell or a battery. Now the next concept is, for example, take this equation. Take this equation. So just now we calculated an equation, right? Node point I am going to write. I'm going to write like a node point. What is the equation? Is V is equal to E minus IR. For example, let us suppose if circuit is open, then I is equal to 0. My circuit is open, then I is equal to 0. Please remember this. If I is equal to 0, then V is equal to E. That implies potential is equal to EMF. Okay. Now please remember, what do you mean by EMF means? Please remember, students. So what do you mean by EMF means? EMF is nothing but, EMF is nothing but potential of a cell or potential drop across the cell, no potential drop across the cell when circuit is open. Okay, so potential drop across the cell when circuit is open. Okay, or you can write like this also. For example, if I take it as a circuit, no, if I take it as a circuit, this is positive terminal of the battery, this is negative terminal of the battery. Now, can you tell me, positive charge will move from where to where? Positive terminal of the battery to the negative terminal of the battery, like this. Are you clear? Then the work done, please remember, then the work done, okay, to move a positive charge. Now the work done to move a positive charge along the circuit, okay, is called as EMF. Please remember this point and definition. So two definitions are there. No? Potential drop across the cell when the circuit is open, that is one definition. Next definition is that the work done to move or the energy required to move a positive charge along the circuit or in the entire circuit is called as EMF. So please note it down, then we'll go for the next point. Is it done now? Next point. If circuit is closed, okay, so please remember, if circuit is closed, then I not equal to 0. If I not equal to 0, then we can write like this. Now, if I not equal to 0, we can write like this. V is equal to E minus IR. Now, if I not equal to 0, then this equation, this term, this is not equal to 0, right? If that is not equal to 0, can you tell me E is more or V is more? 1 minute. Yeah, can you tell me E is more or I is more? Sorry, V is more. So in this equation, I told I is not equal to 0. If I is not equal to 0, can you tell me V equal to E na, V greater than E na, V less than E na? Yeah, please replace students.
E is greater than V.
Very good. Right, E greater than V, because if you subtract E minus something, you are getting V. That implies V is less than E. Please remember. So what is the meaning of this? Means potential is less than the EMF. Okay, so potential is less than the EMF. So please remember, from this equation we can say potential is less than EMF. Okay. Then shall I move to the next concept?
Yes, sir.
Yeah. Then please remember, one note point I'll give you, one more note point. Okay. So two note points we discussed: when circuit is open, circuit is closed. Now the next note point is, okay. So we have I is equal to E by capital plus smaller, where capital is the external resistance, smaller is the internal resistance. So the concept is to get a maximum current. Okay, to get the maximum current in the circuit. Okay, the condition is smaller must be equal to capital. Okay, to get maximum current in the circuit, smaller equal to capital. If smaller equal to capital, then current I is equal to E by, this is how much, 2 capital. Or you can write I is equal to E by 2 smaller. Is it okay, students?
Yes, sir.
Yeah. Then please remember, if I take power, now if I take power, what is the formula for power? Means P is equal to I square R. Then if you take in terms of this one, then you can write it as E square R by R plus smaller whole square. For example, if I take maximum current, then power is also maximum. Therefore, for maximum power, now please remember, for maximum power, okay, for maximum power, P maximum, the value is E square capital R by, you can write it as 2 capital R whole square or else 2 smaller whole square. That can be taken as P maximum is equal to E square R by 4 small r square. This is the power maximum. Shall I move to the next point? And remember, tomorrow also I'll take the class even though Saturday, because I'm missing few classes. Because of that, I'll take tomorrow also class. And Sunday you have test on. Sunday you have test on capacitors concept.
Sir, tomorrow is only Sunday, right?
Oh, sorry. Tomorrow. So tomorrow only you have exam. Okay. Sorry. Shall I move?
Yes, sir.
Yeah. Now read on combination of cells. In that first one, series combination. Okay. Now in series combination of cells, let us consider this is one cell with internal resistance R1, EMF E1. I'll take this as second cell with internal resistance R2 and EMF E2. And I'll take it as third cell with internal resistance. I'll take like this first, for example, with two cells we discuss. Okay. Now I'll take this point as A. I'll take this point as B. I'll take this point as C. Now these two cells are connected in series. These two cells are connected in series. And let us consider I is the current passing through the cells. Now please remember, in series combination, current I is the same way. Now in series combination, current I is same. Now can you tell me what is the potential drop across AB means? Now what is the potential drop across AB means? Potential drop across AB can be taken as VA minus VB. That can be taken as E1 minus IR1. Shall I write like this or not? If you have doubt, ask me, I will tell you. Yeah, nothing but VAB is nothing but terminal voltage across the cell. Just now we discussed. Terminal voltage across the cell is given as V equal to E minus IR1. Okay, so in the previous concept only we discussed the terminal voltage across the cell. So terminal voltage across the cell is VAD, which is equal to E, that is equal to E minus IR. Okay, so that concept only we are applying here. Terminal voltage across these 2 points, that can be taken as terminal voltage across the first cell, which can be taken as VAB, which is equal to VA minus VB, that is equal to E minus IR. And similarly, terminal voltage across the second cell, okay, VBC, that can be taken as VB minus VC, which is equal to E2 minus IR2. Now please remember students, add these two. If you add these two will get cancelled. Then VA minus VC, that is equal to E1 plus E2 minus I, if you take it as common, R1 plus R2. This VA minus VC can be taken as VAC, that is nothing but potential drop across the cells, which can be taken as, you can write it as E effective. E1 plus E2 can be taken as E effective. Okay, 1 minute. E1 plus E2 can be taken as E effective minus I into R1 plus R2 can be taken as R effective. Are you clear? Therefore, effective combination of cells. Clear? Therefore, effective combination of cells can be taken as E effective is equal to E1 plus E2. Please remember, effective internal resistance. Clear? Effective internal resistance. So effective internal resistance can be taken as R effective is equal to R1 plus R2. Okay. Now please remember, for example, if I take for N cells, then E effective can be taken as E1 plus E2 plus E3 plus and so on plus En. And similarly, R effective can be taken as R1 plus R2 plus R3 plus and so on plus Rn. And similarly, if I take for N identical cells, what is the difference between N cells and N identical cells? Yeah, can you tell me what is the difference between N cells and identical cells? N identical cells means all the cells are having same EMF, correct? And same internal resistance. Okay, so all the cells are having same EMF and same internal resistance. So then we can write E effective can be taken as NE. E effective can be taken as what? NE. Then R effective can be taken as NR. Okay, so please understand this. If you're done with this, I'll go for the next concept. Shall I move? Yeah. Yeah. So the next concept is mismatching of cells. For example, I'll take it as first cell of EMF E1. I'll take second cell of EMF E2. I'll take third cell of EMF E3. I'll take fourth cell of EMF E4. Like that, I will take the cells. Okay. So I'll take the cells as E1, E2, E3, E4, and so on. For example, what is the effective EMF of this means? The effective EMF of this is E1 plus E2 plus E3 plus E4. Now, what I'm going to do is, I'll take it as a first cell, I'll take it as a second cell, I'll take it as a third cell, I'll take it as a fourth cell. Now, in series combination, always remember positive terminal and this is negative terminal. Negative terminal of the first battery is connected to positive terminal of the second battery. Negative terminal of the second battery is connected to positive terminal of third, and so on. But in this fourth cell, no, but in this fourth cell, negative is connected to negative, which means that this cell is mismatched. Then how many cells mismatched? We have to separate the EMFs. If I take first EMF E1, second EMF E2, third EMF E3, fourth EMF E4, then effective EMF can be taken as E1 plus E2 plus E3 minus E4. This is the concept of mismatching of cells. For example, let us consider this is cells. I'll give you an example. Let us consider these are cells. One cell is mismatched. All the cells are having same EMF. Now, can you tell me what is the effective EMF across the cells? Is it done, no? Tell me the answer.
IV.
What is the answer?
IV.
Yeah. So total 4E minus this is 1E. That's it. That is equal to how much? E effective is equal to how much? 3E. That's it. Now in the same above problem, I'll take it as first EMF, second EMF, third cell, fourth cell, fifth cell. Now can you tell me what is the answer?
E.
Yeah, very good. Because 3 cells of EMF, 3E, minus 2 cells, minus 2E, which is equal to E. Okay, na? Yeah, 1 minute, students. Yeah. For example, are you done with this up to there? The previous problem? Done up to the previous problem? No? Now listen. If n cells are connected in series, okay. Now I'll take the cells as identical cells. Okay, I'll take that cells as identical cells. For example, if n identical cells are connected in series, okay, if n cells are identical cells are connected in series, in that n cells are mismatched, then m cells are mismatched, then the effective EMF is given by n minus 2m into E. So please remember this. But then the effective EMF is n minus 2m into E. That is the effective EMF. Okay, please note in this point. If you're done with this, I'll go for one more concept and we'll finish it off today. Shall I move?
Yes, sir.
Now write down cells connected in parallel. Now write down the cells connected in parallel. Okay. Could you hear me? My voice is audible.
Yes, sir.
Now listen. I'll take two cells. This is first cell of EMF E1 and internal resistance R1. I'll take it as second cell of EMF E2 and internal resistance R2, which are connected in parallel like this. Now I'll take this point as A, I'll take this point as B, I'll take this point as C, I'll take this point as D. Then in parallel combination, potential drop across AB must be equal to potential drop across CD, that I will take it as V. And let us consider current in the circuit as I. Here let us consider current in the circuit as I. Then this current divides into two parts now. I'll take the current here as I1. I'll take the current here as I2. Okay. Then please remember, then we know that E is equal to V plus IR. Did you see this relation? Did you observe this relation? Or else we know that V is equal to E minus IR, that is terminal voltage. When V is equal to E minus IR, that is terminal voltage. Then we can say like this: terminal voltage across the first resistor is equal to, you can write it as E1 minus I1 R, R1. Okay, and similarly, VCD can be taken as E2 minus I2 R2. Okay, but potential drop across EAB and potential drop across CD both are same. Then that implies V is equal to E1 minus I1 R1, and you can write V is equal to E2 minus I2 R2. That implies you can write like this: I1 R1 is equal to, okay, E1 minus V. Just 1 minute, give me 1 minute. Yeah, I1 R1 is equal to E minus V, or that implies R1, sorry, I1 can be taken as, okay, or that implies I1 can be taken as E1 minus V by R1. I'll take it as equation number 1. Okay, I'll take it as equation number 1. Now, similarly, I2 can be taken as same from this equation. You can write I2. I2 can be taken as E2 minus V by R2. I'll take it as equation number 1. Okay, but from parallel combination, you can write like this. From parallel combination, we can write like this: I is equal to I1 plus I2. Okay, now substitute I1, I2 value in this equation and tell me the answer. Now substitute I1, I2 in this equation and tell me the answer. 1 minute. Yeah. So if I substitute, did you substitute? If I substitute E1 minus V into R1 or V by R1, no, E1 minus V by R1 plus this can be taken as E2 minus V by R2. This can also be taken as E1 by R1 plus E2 by R2 minus V into 1 by R1 plus 1 by R2. Shall I write like this or not?
Yes, sir.
Yeah. Now please remember, I'll go for the next page, or else here I'll write. So please remember, for example, if you take E1 by R1 plus E2 by R2, this can be taken as E effective by R effective. And similarly, 1 by R effective can be taken as 1 by R1 plus 1 by R2. Okay, so this is taken as, this equation is taken as what? E1 by R1 plus E2 by R2. This is taken as what? E effective by R effective. 1 by R1 plus 1 by R2 can be taken as what? 1 by R effective. Please remember this. Okay, or else from this equation we can write I is equal to E effective by R effective minus V into 1 by R effective. Okay, or multiply this entire equation with R effective, then you can write like this: R effective into I, which is equal to E effective minus V. Okay, or else V is equal to E effective minus I into R effective. This is the equation. This is for parallel combination. Okay, now please remember, students, here E1 by R1 plus E2 by R2 can be taken as E effective by R effective. This is most important conclusion, please remember. So in parallel combination, directly E effective equation we will not get. We will get E effective by R effective. Then how to find out the E effective values? Divide E effective by R effective divided by 1 by R effective. Then 1 by R effective, 1 by R effective will cancel. E effective by R effective is how much? E1 by R1 plus E2 by R2. whole divided by, this is 1 by R1 plus 1 by R2. 1 by R1 plus 1 by R2 is R1 plus R2 divided by R1 R2. Then that implies, again, if you cross multiply this, E1 R2 plus E2 R1 divided by R1 R2, R1 R2, R1 R2 will cancel, divided by R1 plus R2. This is the effective EMF value. Okay. Please remember, this is most important concept. Bit confusion is there, but do step by step, you will understand it. So in series combination, you will get directly E effective, but in parallel combination, you will get E effective by R effective. Then how to calculate E effective means divide that equation, you will get the required answer. Is it done?
Yes, sir.
Yeah. Now please remember, for example, for identical cells, but two cells are identical. For example, identical cells. Now, what do you mean by identical cells? What do you mean by identical cells?
Which has the same length and same internal resistance.
Yeah, same EMF and same internal resistance. For example, effective EMF by R effective. Okay, so all are having same EMF, right? So if all are having same EMF, you can write like this one. So then 1 by R effective. Now 1 by R effective can be taken as, now 1 by R effective can be taken as N by R, or else R effective can be taken as R by N. So in parallel combination, you know this. Then if all the cells are having same EF and same internal resistance, E by R plus, E by R plus, E by R plus, E by R plus, and so on. That is nothing but, no, that is nothing but E effective divided by R effective is equal to N E by R. Okay, so that is E effective by R effective. Okay. Now this is E effective by R effective. And we know that 1 by R effective, now we know that 1 by R effective is equal to N by R. We already calculated this. Then how to calculate the E effective value? E effective value can be taken as E effective by R effective whole divided by 1 by R effective. Now E effective by R effective is NE by R, and R effective is equal to N by R. Now cancel E and E, N and N. So please remember, this is most important conclusion for N identical cells. Okay, for example, for N identical cells, effective EMF is equal to E only, not NE or ME. In which combination? Parallel combination. So in parallel combination, effective EMF is how much now? E only. Whereas if you take resistors, in parallel combinations, effective resistance is taken as what? R by N. R by N. Are you clear? And series combination effective resistance is taken as NR. In series combination effective resistance is taken as NR. Whereas for N identical cells, E effective can be taken as what? No, E. Not N by E or NE. Understood this point, students? And similarly, for example, if I take some cells without internal resistance, now I'll take some cells without some internal resistance. For example, I'll take 3 cells now, 1 volt, 2 volt, 3 volt, without internal resistance, I'm telling. And I'll take 3 cells like this, 1 volt, 2 volt, 3 volt. Now, please remember, in the first case, all 3 cells are connected in series. Can you tell me what is the effective EMF? Can you tell me what is effective EMF?
Six volts.
Yeah, 6 volts. Now in the second case, what is the effective EMF means? In parallel combination without internal resistance, cell with the highest EMF is the effective EMF. That's it. So 3 volts is the effective EMF. Okay, now? So please do it. Then we'll discuss the Kirchhoff laws tomorrow. Please do it now. If you're done with this, you may leave the class. We'll discuss tomorrow.
Thank you, sir.
Yeah, fine. So you may leave the class now if you're done it. Yeah, fine.